am Revati, Assistant Professor, Department of EEE, SNS College of Technology. In this lecture series video of Fundamentals of Electrical and Electronics Engineering, today's topic is uninterruptible power supply, so which is commonly known as UPS. So, backup powers, protect devices from interruption, ensure clean and stable supply. So, what is an UPS? Why we need UPS? User need in power backup system, need for reliable uninterrupted supply, and use UPS designing concept. We are all gonna discuss about these topics in this video. So, uninterrupted power supply is a problem faced by the users. Frequent power failures, sensitive electronic loads, voltage fluctuations, sudden shutdowns of devices, data loss in computers. These are all the important factors which leads to a power supply cut. So avoiding all those problems, we are using an uninterrupted power supply for the continuous power supply. So voltage drop, voltage spike or power outage is major causes for the usage of UPSs. So what are all the, why we are need the uninterrupted power supply is it acts as a backup power capacity, runtime requirement, voltage regulation and protection, scalability and monitoring. So key requirements are fast switchover, battery backup, noise free power, overload protection, easy maintenance. User need a reliable UPS that ensure continuous power, protects electronics and switches instantly during failures. So this UPS is act as a battery which stores the DC, which stores in a form of DC, collecting an AC supply, converting it into a DC and rectifier. So it source energy in the battery and then it's converted the DC source into an AC source and we will get the supply through the UPS. So these, what are all the types of UPSs or online UPS and offline UPS? In the residential area, we are using a wide variety of offline UPS. So there is a switch over. So there is a break time for a switch over from a main supply to an UPS. Whereas in online UPS, there is no break time gap. So there is a fast switchover in an online UPS. We can see that in a computer system laboratories, etc. So there is no cut-off power. There is a continuous supply to the UPS. So this is the design concept of UPS. So running on normal power supply, it acts as a charger and stores the charge in the battery, and then it converts the charges to an AC supply to an inverter, and then it's given to the load. So under voltage or power losses, the battery inverters act as a main switch. So in this switching supply, we are using a SC or silicon control rectifier for a fast switching experience. So this is connected to one load. So evaluating offline and line interactive online UPS motion options, explore fast switching static switch concepts, select optimal rectifier inverter battery management, proposes energy efficient power conversion methods. So in online UPS and offline UPS, there is a lot of comparison between that power flow, transfer time, power quality, cost, protection level, uh, cases, efficiency. So comparing to the cost test, online UPS is higher and offline UPS is lower. Power quality is excellent in online UPS and depends on main supply quality in offline UPS. Transfer time is 0 millisecond, no interruption in the online UPS. But in offline UPS, there is a delay time for 4 to 10 milliseconds. So power flow is always power loads through inverter, load normally powered by mains. So where we are using is data center, medical devices, servers in online UPS, whereas in offline UPS we are using it in homes, PCs, small offices, etc. So heat is more in online UPS due to continuous supply. Comparing to that, offline UPS is less heat. So efficiency is slightly lower, double conversion, where in offline UPS it is higher efficiency because it is mainly switched on the direct main supply. So protection level is high, ideal for sensitive equipment, moderate. So this is for basic protection. We are using that in offline UPS. So these are all the main differentiation and comparison between online and offline UPS. So in line interactive UPS, optimal battery charges for longer backups life, identify fast switching mechanism to reduce transfer delay, consider energy efficiency inverter designs, include surge protection and brownout correction. So explore automatic voltage regulator AVR integration systems are all used in the line interactive UPSs. So these are all the basic assessments of UPS. So reference video is given. Thank you.